Good morning, everybody. Thank you so much for joining us here this morning. I don't know if it's raining where you are, but I know it just started pouring here in Champaign. But thanks for taking a little bit of time to join us today for our Illinois EPA Office of Energy Public Water Infrastructure Energy Efficiency Programs Fall Webinar Series. So today is the third webinar in our series. And of course, we're so excited that you're here. If you hadn't said hi in the chat yet, please do. It's fun to see where everybody's joining us from today. And so my name is Cassie Carroll. I work at the Smart Energy Design Assistance Center, and I'm a program director. I'm here with CDAC's technical director, Sean Maurer, to deliver this program to you today. He'll introduce himself in just a moment. Before we get rolling, I just wanted to mention a couple of Zoom housekeeping items. So please use the chat throughout our session today. If you have ideas, if you have comments, please feel free to bring them to the chat and share your thoughts and ideas with others in today's call. If you have a question, please feel free to use the Q&A box that should be at the top of your screen next to the chat button. And we will collect questions and have a Q&A portion of our webinar. Also, this event is being recorded, so the recording and the slides will be shared later today or early tomorrow. So please feel free to refer back to them if you want to reflect on any of the content that's shared today. We'll email those out to you. And then, of course, we have applied for CEUs for this course. They are not, our course number and CEU number is not available yet, but never fear, they always come through for us. So CEU and PDH certificates will be available for all events in this series and will come to your inbox as soon as they're available. And thank you all for your patience as always with getting those course numbers out and checking in. We're excited that we're able to offer those to you as well. So our event today focuses on implementing automation strategies for time management and activated sludge systems. We know you all have a lot on your plate and not a lot of time, especially in smaller communities where you all perform other duties for the municipality outside of your wastewater and water treatment roles. So today we'll kind of look at how activated sludge plants can deploy automation to help operators save time on maintenance, documentation, and monitoring of equipment. As a result, we hope you'll gain more visibility into your plant's operations and even be able to maybe operate your plant from remote locations. So we'll discuss a little bit about automation at any level today. And we have some awesome speakers joining us today that will be sharing their knowledge with you. And my colleague Sean will be introducing them those speakers to you shortly. But first, just wanted to let you know that at CDAC, the Smart Energy Design Assistance Center, really our goal is to help reduce the energy use of all in Illinois and beyond. We just really want to help find solutions that reduce your costs, but also help you be more efficient and effective at the jobs that you do. And we partner in the Illinois EPA Public Water Infrastructure Program with the Illinois Sustainable Technology Center. And we have Bill joining us today to share a little bit about the ISTC. Bill?
Well, thank you so much, Cassie. As you can see there, the ISTC's mission is to encourage and assist citizens, businesses, and government to prevent pollution, conserve natural resources, and reduce waste to protect human health and the environment in Illinois and beyond. And I'll translate into that. We like try to help people find ways to be more efficient, more climate resilient, and save money doing that, as well as find the money to get those projects done, which our partners here at CDAC also love to do, and we both love to do for all of our municipally owned water and wastewater treatment facilities. So we are very happy to be partnered with CDAC and working together to help you all, and also great to take part in all their educational webinars here, which I learned so much about the systems out there, and learn to be able to help you guys. And thanks again. And all of you who have not signed up out there, I'll plug in for the programs for both teams. Hey, sign up. The queue is filling up fast. And I see some of my neighbors there in like Salem, and we've already done Collinsville and met Joe there in Effingham. So glad to see you guys, and everybody. Let's save some energy. Thanks,
Awesome.
Kevin.
Yeah, thank you, Bill. We're excited to be partnering with you too and the Illinois EPA to deliver this program. It's so fun to see all the different plants that we've worked with and folks that I've reached out to and spoken with in the past. But I will turn it over here to Sean to talk a little bit about Bill mentioned signing up. What is that? What are we signing up for? And what is included in the Illinois EPA Public Water Infrastructure Energy Efficiency Program? Thanks, Sean.
Thank you, Cassie. So we've partnered with the Illinois EPA Office of Energy to offer no-cost assessments for publicly owned wastewater and water facilities. As part of that program, we'll come out, do a site visit, we'll walk through your facility, looking for energy savings opportunities, efficiency upgrades, new technologies. And we'll come back to our office and we'll develop a comprehensive report that's going to list the cost of those upgrades, the potential payback period, your energy savings and your utility cost savings. And we'll also go through any potential incentives and funding opportunities that can help you fund those projects. And then we also provide training events such as this one to provide continuing education credits for operators for both water and wastewater. Go to our next slide. Why might you want to complete an energy assessment? If you have an older existing system or you've not had a previous assessment, we can identify missed opportunities, low-hanging fruit. We can help you plan for capital improvement projects. We're actually working with a number of plants right now that are in the midst of planning for significant upgrades to their facilities. Uncover any potential possibilities for energy savings, CHP systems. We cover a whole wide range of opportunities. And we also offer that third-party support for your ideas. When we come out to these sites, we're not just operating in the blind. We're going to ask you what you want to see in your report. And we'll try to incorporate that in there as best as we can so that you get somebody's support for ideas that you've already got for your facilities. You can take that back to your budgetary committees, your city council, whoever you need to talk to, so that you've got some outside support that says, look, this is a good idea. It's going to pay back well. And we should do this. On the other hand, what if you have a brand new facility? Shouldn't that already be as efficient as it can be? Well, there's always more to improve, and we always know there's budgetary constraints to projects. We can't always do everything we want. So there's always some kind of opportunity left on the table, and we can help identify those and let you know, is this good to pursue in the future? Is it something to dig into? Are there other opportunities that we didn't even consider? And then technologies are always advancing. There's always something new that's come up out there. We're always trying to dig into those and find out what they are. And so we'll help identify those and see if any are applicable to your process. So how do you apply for an assessment? Go to our website, www.smartenergy.illinois.edu/water. And there's an application button there. You click on that link, fill out that form, and you'll be connected with us. In order to qualify, you must be located in Illinois and be publicly owned. You've got to agree to allow us to come out to your site, take some pictures, document what's in place there. We can also do remote visits. We did that a lot during the COVID era. If that's something that you're interested in or is more beneficial to you, then we can do that as well. Be willing to share facility information. We're gathering things like utility bill information. Sometimes we'll gather SCADA data to help in our analysis. And then you got to be willing to share that final assessment report with the energy office. It's a non-regulatory thing, so you don't have to worry about if we uncover anything, any concerns there. All we're documenting for them is the effectiveness of the energy savings program. What did we find? What's been recommended? Are you going to implement any of those things? So we're just tracking the performance of the program. So that data collection, again, once you've got that application form in, we're going to get 2 years of utility bills. If you're in Ameren and ComEd territory, that's really easy. We can pull that information with just an account number. If you're in a co-op or something, then we'll need your assistance to get that pulled together. We'll gather some initial facility information. We can pull your discharge monitoring reports. So we have that information. We'll pull that all together. We'll do some initial benchmarking of your facility so you know where you stand relative to others, and then we'll schedule the site visit. So for today's webinar, what we're going to talk about, automation for time management. How can you use automation to free up some of your time for your other duties on your site and to be more efficient overall? Joining us today is Brian Vu. Senior Practice Solution Architect from Xylem. So he'll be talking a little bit about his experience with new controls. And then we'll follow up with Jeremy Henning, the Assistant Executive Director at Glenbard Wastewater Authority, talking about some of their in-field practices and give you some of that practical application. So Brian, go ahead and take it from here. You'll need to unmute.
All right, can everyone see my screen? I'm just making sure that that's good.
Yes.
Okay, so we're going to talk about implementing automations and time management in wastewater plants. Some of my experience with it as a wastewater operator. So I served 16 years on the municipal side before coming over to Xylem about 10 months ago. So right now my role in Xylem is Senior Practice Solutions Architect. I oversee wastewater treatment for North America for our digital solution. So using digital technologies to optimize treatment plants and help operators like you guys better perform your job. So so being an operator is a difficult job, right? We're dealing with more severe weather, budget constraints, and changes in our regulatory requirements. These are things that we can't really control as an operator. So let's focus on things that we can control to help us to make our lives easier and produce a better product, right? So these are just some slides from previous life of mine running wastewater plants. But we always had as saying, like, there's always a fire to be put out when you're an operator, right? So this is a picture of a couple operators that I had. We had a sludge line that plugged up with a bunch of grease, basically shut our whole entire sludge operation down, which is like a 365 day, 24/7 operation. So it's all hands on deck when something like this comes. And this is something that we can't predict, can't foresee. And these are what we call, operational fires that are happening. And it could be a sludge line plugging, or it could be an industry dumping something on you that you're not knowing about, right? You didn't plan for this. This was an industry that dumped a bunch of stuff onto us, caused basically a scramble to move all our influent into storage, and it puts a lot of strain on operations from our daily task, right? Or it could be that, like we said, that intense increased weather. Like this is another plant that I operated. 2013, we had a flood situation, basically a brand new plant. After expanding and renovating it, a couple of months later, we basically almost lost it from a flooding situation that happened here in Michigan. So these are things that we can't prepare for as operators. And so what can we do to make our jobs easier? That's what we're going to look into, right? So operators wear many hats, right? Some days you're asked to be a biologist, maybe a chemist. Sometimes you're asked to go help maintenance out and repair some pumps or some broken equipment in this field. On top of your regular duties, you're asked to do all these things. And even sometimes you're even asked to become a weatherman, predict the weather. We got a storm coming in. What's going to happen to treatment? How do we divert? How do we handle this flow? These are things that are challenges every day that we face, right? So these are reasons why automation is key for operators, right? Putting in automation can help reduce energy costs, improve process stability, give you constant data access to have insight of what's actually happening within your wastewater plant. It can help you reduce chemicals and additives, and it can basically give you that stability to allow you to make better use of your labor, right? Instead of having to watch a process operate in hand, we can add some automation, let's say like a screen building. And we'll get into some examples of that, right? So automation pretty much from inside the fence and even outside the fence can be added pretty much anywhere, starting from pre-treatment to lift stations, chemical dosing. We can add it on anaerobic digestion, maybe some gas cleaning. Clarifiers can be automated. Aeration can be automated with some DO control. Disinfection can be automated. Basically anywhere within your plant, we can add some type of form of automation. So automation starts out with SCADA, right? If you have a SCADA system, it pretty much gives you this insight of what's going on and allows us to view our plant from one desktop, right? So some of the primary functions of SCADA is data acquisition, right? We're acquiring data within SCADA. We're storing that data for future use for either reporting or trending within our operations. We're creating a network communication, a data network communication, so that the plant can communicate back into SCADA, presenting the data in a visual format for operators to be able to see and look at what's going on in the whole entire plant without having to make a trip around the plant. And we're having the ability to create control logic within SCADA too. So some of the four main components of SCADA are inputs from your equipment outside in the field, remote telemetry, that's controls used for controls, some type of human interface so that we can see, visualize, and some type of communication that we can get back and communicate and control things remotely from SCADA. So this is kind of like just a display of how this works. You have equipment out in the field. That equipment talks to some PLC, with some control logic in there. It's bringing in data, some data, and the ability to control that equipment remotely through some human interface, which is usually laid out in some type of computer format. So, and where can we add this type of technology, right? We talked a little bit about briefly, but this is just a plant overview. So we're going to focus today a little bit on aeration, but we'll talk about how we can optimize or add automation within aeration. You can do this in activated sludge, aerobic sludge plants. You can do this in some gas controls. So if you're producing gas from anaerobic digestion, gas cleaning systems are very highly automated. It's not something you'd want to manually run. We can do some power distribution, so maybe using that gas to produce some energy. This gives you a chance to control switch gears throughout remotely through SCADA. We can add this into disinfection, as mentioned before, UV, or if it's chlorine disinfection, both can be automated. Sensors are key, and we'll get into why sensors are key in this. Chemical dosing as well. Maybe you're adding some iron salt or some metal salt for phosphorus removal. Controlling dosages on chemical dosing is important, reducing costs and overusage, right? Solids handling, same type of thing that in chemical dosing. We got polymer that we're dosing. We can automate polymer systems. We can automate, dewatering equipment, centrifuge equipment. Those are all things that you want to look at automation for. Collection systems, lift station automation is a key. When to turn pumps on, rotating pumps, keeping a steady flow within the system, that can be automated. And then pre-treatment, I think there's a lot of automation that goes in there. Grit removal can be automated, grit cleaning can be automated, and screens definitely can be automated too to remove any debris that's coming in the plant. No one wants to spend a whole day in there just running this on hand. So automation, we talked a little bit about SCADA. We can deploy, we can visualize a lot of different things within SCADA. And this is just a kind of an example of what you can visualize. You can have incoming data coming in, actual set points and actual control points within your plant. You can visualize those. If you have some type of recommendation system, we can propose set points. So it gives you some operators some insight in what we should be looking at changing within the plant. If you have that same prediction thing, we can even create some flight simulators to be able to run scenarios in the plant without actually put those in effect. And then you have some outcoming effects like current values that are going out in your effluent that you can see. And if you have that prediction tool, you can do some prediction feed forward type of stuff to see what could be happening in the future. So here's another example of automation. So this is a digester system. We got sludge pumping going on here. We got mixing going on in this tank. We have pressure that we're seeing, level indication that we're seeing, temperature, trying to keep a temperature set point. So this is a highly automated system. We got valves that we can operate over here on this left-hand side to switch from primary tank to primary tank with sludge pumping. We can remotely control and automate pumps when they come on and off. We can visually see what pressures are happening within the tank, changing automated valves to change mixing cycles within the tank, temperature readings to send back the signals when we heat and when we don't heat. So this kind of gives you an idea of how you can apply automation on a highly complex system like this that makes it fairly simple to operate. So now that we've talked a little about how we get to the automation, let's talk a little bit about how we can optimize. And we're going to focus in on the secondary treatment. So automation in the secondary treatment usually has some type of sensor network deployed. So usually typically what you'll see is for standard controls, for blower controls, you'll see DO and TSS. We're just kind of monitoring our biology within the collection system, within the treatment system, and making sure that's happening and sending that system back, that signal back to conducive controls. And we'll talk about how we do those controls. But if you get into some more advanced controls, you're putting sensor networks now in the maybe in your primary effluent, and then maybe sometimes in your final effluent, and we'll talk about how those sensor networks can be used. So your typical process here, your blower control, let's say you have a blower that's providing, so let's step back. This is your typical, let's say a BNR plant. Maybe you have some nitrification, denitrification happening. You're pushing some air into a tank for nitrification. Maybe you have some recirculations for your denitrification process. Maybe you have some return sludge for your final process. These all can be automated using that what we've talked about before. And you deploy some sensors in your aeration process, DO sensors, and then you have a blower. So maybe you have a set point that you're trying to keep 2 milligrams per liter of DO. Those DO probes are sending a signal back into SCADA. SCADA is reading that. The system basically is deploying. If DO gets too high, the blowers will ramp down. If DO gets too low, the blowers will speed up. This is a typical control set point for an activated sludge plant, right? So you get into some more advanced controls, a feedback loop. You're using that same type of control system. You got influent coming in. You got some DO control here, sending a set point back to SCADA. And then you can take your ammonia probes. Let's say you place some ammonia probes in your final effluent. You can get an ammonia signal. That's really what you're treating for, right? Anyways, not DO, but ammonia. Sending that ammonia signal back into SCADA, and then that can send a signal back into your blowers to ramp up and down based on ammonia loading on the back end. So that's a typical feedback control. A little more advanced than your DO control. You get a little more aeration energy savings from that, based because you're treating what's actually coming out the back end and kind of predicting that it will, if your ammonia increases, you need to increase your blower speed. If it decreases, you decrease your blower speed. Go through all this automation. So this is a feed forward feedback controls, which is a little more advanced than the feedback controls. So now we're increasing in our advancement and in the ability to save energy. So you got your same DO probes in your aeration tank that are monitoring DO. You got some controls in the back end, and they're going to be used differently in a feed forward system. So in this system, we've deployed some sensors in the front end. We're actually measuring what's coming into treatment. And when we know what's coming into treatment, we can use that information and run it into maybe, like, say, advanced model. So that advanced model can do some predictions, give you some predictions on what's going to happen. So let's just run a scenario saying that 4 o'clock, you have an industry that discharges on you. At 6 o'clock, it's going to hit aeration. If you can see that in the sensor network deployed in the front that feed forward, we can start to run scenarios and predictions what will happen 2 hours later. And from those predictions, we can create recommendations to what we should recommend the plant should be set at. So where should that DO set point be at? So we can change the blower speeds and recommend it so that we can prepare for treatment that's going to happen in a couple hours. And let's say that effluent's going to come out at, let's say, 8 o'clock. So we have 4 o'clock, we see that reading. 6 o'clock, it hits treatment. 8 o'clock, it finally is treated. we can measure the effluent quality. And from those predictions and recommendations we made, we can feed back and check those recommendations. And so this is a type of a machine learning aspect in controls, using a digital twin to do predictions, a neural network to create some decision making, and then feeding forward and feeding back to get better treatment. So just three types of control systems that you could add to aeration all have their advantages, and they all kind of build upon each other as we move forward in our automation. So what kind of operational benefits can adding automation to your plant provide you? So operational continuity, and that means so many different things. Building continuity within your operating staff, really having an understanding of why we're running things. So having some control logic that everybody understands and knows why things are happening in certain areas can lead to some troubleshooting as well. But it also helps bring that plant into a steady state. And when we can bring that plant into a steady state, we see better performance in our effluent quality, but we also see better performance in our energy savings as well. So building that transparency, through SCADA, you can visualize what's going on in the system, allows new operators to really understand what's going on, even the older operators understand what's going on. And then some of those things like the technology where you could add flight simulators is giving the training tool for an operator. So they're able to run some just different situations to really understand how that plant will react. For some predictive insights too, is if you get into that machine learning type of technology, you can create some predictive insights on what's going to happen. So operational improvements, obviously we're hoping to save a lot of chemicals. We're hoping to improve our effluent quality. We're going to try to save some energy, and anytime we can save energy, we can reduce carbon footprint. And then what's the other supports, right? We have some alarm systems that gives an operator some input and when things are going bad and where to go and give that support to. And then building a SCADA system and automation, we have future connectivity. As we start to build this and within the fence, we can start to deploy this throughout the system and increasing our savings and energy costs. So that's kind of the brief overview I had. Obviously, here's my information. If you guys have any questions, learn about what we do for automation and what technologies we have to offer, I'd be more than happy to answer those.
Okay, I've been scanning the chat. We did have a comment that came in. We had someone mention that automation can also help reduce shift work. You can monitor things during off hours and send people out when they're needed. But it's increasingly difficult to find people that want to work outside that 9 to 5 window. So, good point there. I did have one question. It actually came up during our Lagoon webinar a while back. But as we're increasing the automation with more sensors at our plant, are you seeing more correspondence between what we're using sensors to read and automatically filling that into, say, like our DMR reports and things like that? Are you seeing automation of actual reporting?
Well, yeah, I mean, so I can speak from my experience as a plant director. So at the city of Grand Rapids, it's the plant I operate, one of the plants I've operated and managed for. We had our biggest problem was our biggest lack of resources, people. We had an 85% turnover rate. We couldn't hire enough qualified people fast enough. And that's to do for a multitude of reasons. We had a lot of people retiring. It's, switching departments and all kinds of other things that were happening. But what we did is we created a sensor network. We deployed all kinds of sensors in the plant. I think 64 of them to be exact within the plant. And we were adding advanced machine learning into our plant. One, to reduce because we couldn't get those people. Two, that shift work, calling people in when you have a short staff. It's hard to get people to come in for overtime when you have issues, right? But then we reduced our lab testing, so process lab testing by 21 tests per week, which was huge, right? Because we couldn't get the lab people. So basically, the people that we couldn't hire in the lab, we were able to reduce that testing requirement, and then create new opportunities too by creating some new jobs to help maintain that sensor network. So just so you're not doing the main lab testing all the day, you get a little bit in the field and do that. So yeah, as far as regulatory requirements go, it gives you a lot of insight. Right now, EPA, at least in Michigan, the Eagle is not allowing us to report from all kinds of sensors. Now there are some, DO that we can report from pH, but like ammonia sensors, ammonia analyzers, phosphorus analyzers, those haven't quite yet been approved for reporting. So it really depends on where you live. I'm not sure a lot what Illinois is doing, but if they're allowing it for reporting or not. So
We did have a question come into the chat too. We have heard some challenges with ammonia sensors in aeration basins, that they require frequent cleaning cycles. Any advice on how to monitor ammonia levels in aeration basins and keep track of those calibration of those sensors?
Yeah, we had, like I said, we ran two different ones. We ran two different brands. I'll try not to mention brands here, but yeah, there's new technology coming out for the cleaning. Some filters, some automatic blowing filters that are out there now, which has improved since I've purchased the last time I purchased the maintenance. But like I said, we had 63 sensors and we're able to narrow it down to basically one person, which we call the ERT, an environmental resource technician, to maintain that sensor network. And if you have a good system employed with good SOPs and when maintenance should be done and cleaning, those activities, those sensors can be maintained pretty easily. It's just keeping that repetitive cleaning, a good program for that. So.
In addition to sensors, do cameras give you a visual look at what's going on? Are there applications for visual?
Yeah, so that you've seen that green incident that we had there at that was at the city of Grand Rapids as well. We deployed cameras. It was one of the projects into our influence, so we could try to get those. But we were using we do have some sensor technology that is measuring color too. So with the cameras and the color, those are important. But like on top of our digesters that we had too, we had cameras placed in critical areas where it's difficult for operators to reach, and yeah, you can put those in, deploy them into your operational control room. Those are helpful as well.
Okay, thank you, Brian, for those insights. So now we'll transfer over to Jeremy Henning with the Glenbard Wastewater Authority. Jeremy, take it away.
Sounds good. Let me get my screen going here. I did not prepare any slides. I'm just going to kind of put my contact info up there so you don't have to stare at just my face while I talk. Can you see just my contact info?
Looks great.
All right. Okay, so thank you, Brian. I really appreciate it. And thanks, Sean, for the introduction. I think Brian really laid the stage for me there, kind of talking through all the potentials for automation processes, et cetera. What I'm going to try to do is give you a few examples that we've used here at Glenbard and how they worked out for us. And I also kind of want to focus on the process for finding some of these adjustments or Easter eggs or what you want to call them, right? Sometimes, things don't come up just by themselves, or we're not actively doing them. So we'll talk a little bit about that. But first, I'll give a quick intro for Glenbard. My name is Jeremy Henning. I'm the Assistant Executive Director for Glenbard Wastewater Authority. We are located in the village of Glen Ellen in DuPage County, Illinois. It's about 20 miles west of Chicago. Our service area covers approximately 14,000 acres. That's about 22 square miles and encompasses the villages of Lombard and Glen Ellen. We do have a couple of small unincorporated areas that are also part of our service area. Our facility was originally constructed in 1977 as an expansion to an existing plant that was owned by Glen Ellen. And as with most plants nowadays, has kind of been incrementally expanded and upgraded throughout the years. And so it's been running for about 41 years since then. The facility is rated for 16 MGD design average flow and a 47 MGD design maximum flow. But on any given day throughout the year, we kind of average maybe about 13 MGD per day. We discharge to the east branch of the DuPage River. Our excess flow was sent to a CSO facility that treats up flows up to 58 mgd. So something that's a little unique for us here at Glenbard. And actually, I wanted to give a quick plug. We did, I meant to say this in the beginning, we did our energy assessment that was just mentioned earlier back in 2020. And I wasn't here for it, but I read through the report at the end, and it looked like it was a really great process. Kind of got a lot of great things came out of that. So a little plug for you there to definitely sign up for that assessment. It was a really great tool for us as we're moving forward with energy assessments. But something that's a little different for us here at Glenbard is we utilize high purity oxygen for our activated sludge process. And an interesting tidbit, prior to 2017, and so this was originally done in 77. Prior to 2017, we actually generated our oxygen on site with a cryogenic plant process. So the original expansion of the plant in 1977 was funded almost entirely by the EPA because of this project. There's obviously some contributions from the municipalities. In 2017, a vendor opened nearby, and we did a little research and found that it was much more economical to truck our pure oxygen in. Incredible energy savings. Surprise, surprise, that generating oxygen is not necessarily an efficient process. And so we now have our oxygen trucked in, and we still utilize that system. We call it, that's a UNOX deck, or our aeration deck. So big energy savings win for us. Just to kind of finish up the summary, we also have anaerobic digesters, 3 of those. We do have 2 combined heat and power engines. And for our tertiary treatment, we utilize disc filters year round. This was upgraded from sand filters historically. And we use UV disinfection for about half of the year. So, all right, I'm going to dive into a couple examples here and kind of talk through some of the ideas and how they came about. And so, first one, and somebody, one of the comments kind of stole my mustard there, but you were talking about shift work. So, prior to 1998, Glenbard was staffed 24 hours a day. We had 3 shifts. And we had 27.5 full-time employees. And so in 98, and there was kind of a few-year process there, from what I understand. I was not here in 98. There was a major SCADA upgrade. So just like we're talking about today, a full SCADA implementation, monitoring, quite a bit of process change and automation. And over those, I would say, a couple of year, 2-3 year period, it was able to actually lower the total FTEs for the facility down to 17.9. So perfect example from that comment that you can actually remove or limit or completely remove overnight shift work. And in our case, we lowered it down 10 full-time employees. So quite a significant amount. We're still hovering close to that number today. And so just one of those blatantly obvious, things to put in place there. SCADA can definitely save you on labor and the amount of time spent working in your facility. So one of the more specific examples, though, is with regards to our aeration deck. So we have, like I said, our pure oxygen deck, and it was put in back in 77. And so that has not yet had a kind of total revamp. Like I said, we're getting our oxygen trucked in instead of generating it. But apart from that, it's been a lot of maintaining and upkeep. That is on the docket for future capital improvements here. We're just not quite there yet. But what we have there is we have 10 separate trains in our aeration deck. And each train has 4 cells, and it's kind of in a serpentine. So the water will actually flow through each particular train. And on each one of those cells is a mixer. So those first 2 trains is actually where we're doing our carbonaceous BOD removal. That's our primary effluent, goes through that train, those 2 trains first. And then it loops back around, and we have the remaining 8 trains where we're doing nitrification ammonia removal. So 40 total mixers. And so previously, these mixers would run 24 hours a day. And there's varying sizes. The first row of mixers that are on each train are actually a little bit larger, and they get a little bit smaller as they go through the remaining ones. And they would just run 24 hours a day. Now, I don't necessarily know the process that came about as to why we decided to try turning some off. I don't know if lot of times this is what happens. Something breaks. That's my guess. Or it's just one of those motivating things. We wanted to try to be more efficient, save some energy. And so we found that we didn't necessarily need to run all these mixers all of the time. And so as kind of an intermediate step, what would happen is operations would go out to the deck, and overnight they would be running all of them because nobody was here. And so we didn't want to risk an issue if nobody's here and necessarily monitoring 24 hours a day. But an operator would go out in the morning and turn off specific mixers, and then at the end of the day would come back and turn them on for overnights. Obviously, that's great because we know that we're saving energy, but that's not a terribly efficient process. And what happens? We get busy, and so either you actually get the chance to go and do it, or maybe you don't. Something comes up and you don't go to turn the mixers off. Not the end of the world, but we know that we're wasting energy and money. Or at the end of the day, maybe you don't get time to turn the mixers back on, and there's the potential for an issue overnight. And so what was put in place somewhat recently was some new wiring, and a panel were installed to allow certain mixers to be turned off and on automatically via timer, right? So very simple application of automation and process control, but the fact of the matter is we knew that we don't need to run them all the time. And so we put something in place to make sure that it actually got done all the time. And we kind of picked and choose which ones we did there. Because of the age of the system, there's some concern about wiring up this automation to some of the mixers that haven't had replaced starters, right? And so something to consider as you're doing a part of these upgrades and processes, if you're going to be putting additional wear and tear onto your systems, you just need to take that into consideration. So we did wire up the units that specifically had starters replaced, so we know that we have some confidence that it's not going to be creating an issue with aging equipment. So that's first example, the mixers there. We saved ourselves quite a bit of time and effort on that one. Next example, we're going to talk a little bit about our disc filters. So like I said, this has been quite a little while now since we swapped out our sand filters to disc filters. But during initial implementation and install, recommendation from the manufacturer was that the disc filters would turn the drum intermittently. So you have your disc and a submerged level here, and it would be fixed and sitting, and it would be filtering, and that at certain intervals it would rotate it and utilize a different portion of the disc, and it would backwash when needed. It was actually doing it based on a differential level between influent and effluent. So when it started to get clogged and there was too many solids accumulated on the filter, it would actually run its backwash cycle and try to clear that off, and it would rotate the drum. Unfortunately, what we found specifically for our system was that we had times where the differential would never get back down to a level where it would return to normal runtime. So we would actually have instances where, we were talking about this today, like the number, we could have potentially 200 to like 1,000 backwashes a day on these disc filter units. And what might happen is it just has a basic counter, and it's not telling us runtime necessarily for these filters, and it would get stuck. And so a couple of the instances, maybe towards the end of the day, would actually just never turn off. And so instead of just having a 20 or 30-second backwash time, it would actually just sit and run because it was never clearing and getting back down to its set point. So another intermediate step in the meantime was to actually increase that set point a little bit and allow it to get back into a zone that was more comfortable. So again, a great solution at the time, but not really the final solution that we wanted. This was kind of a Band-Aid. And so an operator, one of our staff actually came up with the idea that what if we just continually rotate the drum instead of incrementally doing it? Now, red flags go off there, right? Why would we want to run something 24 hours a day when we should be running it only incrementally? But the big differentiator here is that the motor that turns the drum is 1.5 horsepower, and the pump that runs the backwash is 30 horsepower. So we found that by rotating it continually, reduced our backwash cycles by approximately 80%. So instead of running 200 to 1,000, we might be running 20 or 30 backwashes a day. And even though we do have to run the drum consistently throughout the day, because of the way that it's utilizing the surface a little bit better, we're able to do those short backwashes, and it does clean them off. And we have overall significantly fewer backwashes that we have to worry about. So kind of a big win. And so what I want to talk about, I do have some other examples, but I wanted to highlight real quick was the process for finding these, right? So we started doing these, and I think this is a common term. We call them like treasure hunts for these energy finds. And what I find interesting is that a lot of times we're just not sure where we should be implementing automation or process control or trying to improve something, right? And until maybe something breaks, or we have an issue with something, or a unit is out of service, and we realize, hey, we actually ran okay with that unit out of service, and we start to look into it a little bit more, there may not be that trigger for us to want to look into changing something. And so I think what we found and has been implemented here recently at Glenbard is to actually just dedicate some time to doing that, going on these treasure hunts and saying, hey, we have this unit that runs like this. Do we really know how many hours a day it's actually running? Or how long does it take an operator, just like we said, some of these manual processes? Overall, do they spend 1 hour a day doing this one manual process? What does that look like? How much does that cost us in manpower? And starting to build an ROI to say, we can actually automate some of these processes and save ourselves on the amount of labor that the operator has to spend and have them doing other things. And so sometimes it just takes that effort to be dedicating time to that thought process, to go out and really try to dive into your process and say, no longer is it just that's the way it was done, and so that's the way we're going to do it. Taking the time and an effort to really kind of dig into it. So I do have a couple other examples. I think I'm gonna stop there and make sure we have enough time in case there was any questions, unless Cassie or Sean, you think we've got time for one more or not.
Well, we did have one question come into the chat, and maybe so a comment for both you and Brian. We had someone ask, could TPOs be on call for midnight when needed? He's heard SCADA can have this option to call TPOs on call during midnight. In that way, she can come to work. So kind of like a remote call out to a trade partner or operator.
Did you want to comment, Brian? Or?
You could take it either way. I mean, I can just say, well, it depends on the SCADA system that you're running, whether you have that option. There is a dial out system. I know for Wonderware has one, but it really depends on their SCADA system if it's provided to have some type of call out where it can send a text to your operator. From my experience.
Yeah. So can you rephrase the question again for me, Sean? So is it just like are we talking like a Win 911, like an alert or something like that?
It just the question was, can TPOs be on call for midnight when needed? SCADA can have this option to call the TPO on call during off hours.
Yeah, the only thing that I can think of that relates directly for us, right? So as a part of our monitoring for offsite, yeah, we just I think we took great pains to make sure that we knew exactly what we wanted to be alerted on in the case of an issue for our monitoring, right? And so set those levels to something that actually makes sense, and so that our overnight staff is getting alerted when they really need to be alerted, based on what we define that to be, right? So that they're not just getting ancillary calls in the middle of the night and, making it be kind of white noise that's, becomes aggravating or defeats the purpose, right? And so you just need to be very purposeful on that, and that they're getting calls or alerts on stuff that really meant something, so that they could take a look at it and determine, remote into SCADA, do they need to come in and take action, or is it something that could wait for the morning? So, I don't know if that necessarily answers the question, but that's the first thing that comes to mind. So sorry.
Another question in terms to remote lift stations and employing automation there to reduce travel time for maintenance and things at lift stations.
Absolutely. So this one's an interesting one that I used at a previous facility before Glenbard, and it's just a little bit of out of the box thinking again. And so we were trying to eliminate truck rolls, like you said, and we had 4G connectivity for all these remote sites. And communicating all that data back to us. And what we found was that these routers would occasionally get stuck. So they were powered on, but we would call our service provider and we didn't have connectivity. We would have like a comm fail. And so we'd call the service provider, I'm trying to be generic and not name names, and mention to them that we didn't have communication. And so they would say, well, we see that it's up on our end. There's nothing we can do. And so, to be honest, we had to send somebody out and they have to turn it off and turn it back on, right? They sit for 10 minutes, it boots back up, communication is reset, right? And so what we ended up doing actually was wiring the power, because this is all 24-volt power to these units. We wired it through process control, just an input that keeps the contact closed. And so when the contact is closed and the PLC is powering the communication, it's good to go. If the PLC sees that it loses communications, we put a timer in place. So it's probably like a 20-30 minute window. If it loses communication, it's not able to ping back to the primary facility. It'll actually open that contact and then close it back in 30 seconds later, and it'll do a power reset for us. So we no longer have to make a truck roll. The operator who's monitoring can wait probably the 45 minutes, maybe an hour, total. Hopefully that's an acceptable window. Obviously you would come up with whatever that is for you, but they wait past that restore time. And so if it's been 45 minutes or it's been an hour and they still don't get communications back, now we can call the service provider and say, we've already done a reboot because it happened automatically via PLC control, and there's something else going on here, right? And so it definitely saves some truck rolls. So it's just, again, sometimes it's out of the box thinking there to implement something that fixes a problem for you.
Hey, great. I haven't seen any other questions roll into the chat. So I guess we have time for one more example if you want to offer one, Jeremy.
Yep, I could do one. The other next one that I was going to hit was with regards to UV, and this one should only take a couple of minutes. So, like I said, it's been quite a number of years now since we put UV in place. One of the advantages and disadvantages, I think, of becoming early adopters is you get to find all the problems and then everybody fixes it and puts in really great systems. And so we're a pretty early adopter of UV here at Glenbard, I believe. And so, but more recently, there was a UVT study done. And as a part of that process, staff was super involved in the study. I don't remember if you guys were involved. No, maybe this was somebody else. But our staff helped perform the testing for them and doing some of the, kind of follow up to see how things were going. And what we found was that the initial set points or levels, just because we were looking at this with a fine-tooth comb, is we have different trains or different channels, let's call them, that we're feeding through UV. And the channel set points were set to, for us, for example, 14.3 million gallons a day per channel was the max. And if it went over 14.3, it would hit the next channel and start it up, right? And so we'd see that we're, running a second channel, a reasonable amount of time when we have moderate flows coming through the facility. And what we found, this was basically just based on level in the channel. And so when they were doing the UVT study in coordination with that, they did some testing. We're actually just monitoring the level at the influent and the effluent of that channel, and found that we actually had a lot more room that we could utilize in each of these channels. And so did a test as a part of that whole process, and we're able to raise that set point limit up to 19 MGD. So we were able to raise 33% increased flow through one channel instead of having to run two and overusing the channels for no particular reason. So for us, this was a 14% energy savings in that particular process. So it's like 1% of total plant energy. And so again, I feel like it's just getting the opportunities to have these deep dives into each of your processes and say, just because, no offense to manufacturers, they say that this is what the set point should be, well, prove it to me. Let us make sure, right? And we still have some gap there. It's not like that was, as a part of the UVT, we ran it at 19 and we knew that we were still getting the throughput that we needed and we're still disinfecting appropriately. So just, hold their feet to the fire or come up with these opportunities to be able to try to find this information out for yourselves. Don't necessarily just trust that because that's always how it's done, or because that's the way the manufacturer says it should be done, then that's the way we have to run it. So things tend to be a little bit more unique in everybody's different scenario. So.
Okay, great. Thank you. Some good practical applications there. I want to thank Jeremy and Brian both for their insights and overview of the control systems and how to use those to save some time for your operators and free up time for other duties and save some energy in the process. So thank you both for all your input. If you have any questions, again, Jeremy's contact information is there on screen. If you had anything specifically you want to ask him about his examples today, Brian, I think we can post your information if anyone has questions in the chat. And then again, if you're interested in an assessment or assistance from CDAC, please reach out to us at smartenergy.illinois.edu/water. We'll be happy to come out and help you figure out some plans.
Thank you, Sean. And just lastly, before we wrap up today's session, just wanted to remind you, we did record today's session and we will have our slides available for review and the recording here either later today or tomorrow. And then CEUs for participating in today's event will be sent out when available. So thank you again, Jeremy, Brian. Thank you, Sean, for leading the ship today as well in our session. I hope you all enjoyed today's session and we look forward to seeing you on our next webinar here soon. We'll send you that information. Yes, have a great week, everybody. Take care. Thank you. We'll talk soon. Bye-bye.
Bye, everyone.
Thank you.